Alright, good day everyone. So welcome back to my YouTube channel. This is Catholic and Vlogs. And today we will be talking about area between two polar curves. So this is calculus 2. So the area between two polar curves here is having a formula. A is equal to alpha, integral of alpha to beta 1 half r radius, or the r squared o minus r squared 1 d theta. So this is the polar curve. RO is the outer and this one is the inner part. And the limit is from alpha to beta. Again, this one is the outer minus the inner. So 1 half and the limit a to b d theta. So steps in finding the area between two polar curves. In order to calculate the area between two polar curves, we will find first the points of intersection if the interval isn't given, and graph the curves to confirm the points of intersection. So we need to graph, and for each enclosed region, use the points of intersection to find the upper and the lower limits of the integration, which is the alpha and beta. For each enclosed region, determine which curve is outer and which is inner, and plug this into the formula for area between two curves. Okay, so let us have first problem number 1. Find the area of the region which is inside the circle r is equal to 2 and outside the cardioid r is equal to 1 minus cosine theta. Okay, so that we are going to look for the region, the area which is inside the circle and outside the cardioid. So therefore this one, okay, we're going to look for this one, and this is the circle. R is equal to 2 and the cardioid, which is R is equal to 2 1 minus cosine theta. First thing that we're going to do is we need to find the intersection. So in order for us to get the intersection, we have to simultaneous or do simultaneous equating of the two equations. R is equal to 2 and R is equal to 2 1 2 times quantity 1 minus cosine. So therefore 2 is equal to 2 times 1 minus cosine theta. So divide both sides by 2. So this will become 1 is equal to 1 minus cosine theta. So we have here uh, negative cosine theta is equal to 1 minus 1. So cosine theta is equal to 0. So cosine theta is equal to 0. So what is the value for our theta? So cosine, inverse cosine theta. So we're going to look for what is the intersection. So in cosine 0 is equal to pi over 2. Theta is equal to pi over 2. So therefore, the intersection of this one, if we're going to have this one, so the radius is 2. So r, let us have r, 2 times 1 minus cosine theta. So what is the value for cosine theta, which is 0? So r is equal to 2 times 1 minus 0. So r is equal to 2. So the intersection is 2 and pi over 2. And also, we could have the intersection, okay, the intersection which is negative, we have 2 and negative pi over 2. So here and here. So x is 2, our radius is 2 and pi over 2. So therefore, since this is symmetric, if we're going to look at here the illustration, this part is symmetric to this part. So therefore, we could only get this one and multiply it by 2. So now we will look for the upper and the lower boundaries of this one, the limit. So let's have first uh, the upper and the boundary. So let's start with the boundary is from 0 here to and pi over 2. So therefore, A area is equal to, so the formula for getting the area is 1 alpha beta, 1 half r curve 1, polar coordinate curve 1, and polar coordinate outer and inner d theta. So we have here 1 half integral of from 0 to pi over 2 here. From 0 to pi over 2, or could have this one going here. But since that is symmetrical, so we could solve this one and multiply it by 2. Okay. So we have here 0 to pi over 2, and we have the first thing is we have to multiply it by 2 since we need to get the area of this one and the area of this one. So 2 times 1 half, and the outer is our circle and the inner is the cardioid. So therefore we have 2 squared, the outer, minus the inner, which is 2 times 1 minus cosine theta squared d theta. So cancel this part. Area is equal to integral of pi over 2 times 4 minus this to become 4 times 1 minus cosine at 2 cosine theta plus cosine squared theta d theta. So simplify this further. Area is equal to 0 to pi over 2. So they have 4 minus 4 and plus 2 cosine theta, and we could have no, this is 8, rather 8 multiplied by 2, and this is plus 4, and the identity for this one is 1 plus cosine 2 theta over 2 and d theta. So the area is 0 to pi over 2. This would become 0, and this is 8 cosine theta plus 2 plus cosine 2 theta over 2 d theta. Okay, so after which we are going to integrate this. So we need to integrate this one. So by integration, so this is 8. Derivative of cos times theta is sine theta. Then plus 2 theta. Alright, this is negative 4. So this is negative, and this one is negative. So negative 2 theta minus, okay, negative cosine 2 theta over 2. Oh no, this is 2 rather. 2 cosine negative 2. Okay, negative 2 and negative 2 cosine 2 theta. And we're going to take the derivative integration of this one. We have 1 half 2 sine theta 2 theta, since there is a neutralizing factor, plus c. So 8 sine theta minus 2 theta minus 2 sine 2 theta and plus c. So this is the answer. 8 sine theta minus 2 theta minus, cancel this part. This is sine 2 theta. Then after that one, 8 sine theta minus 2 theta minus sine 2 theta from 0 to pi over 2. So let's copy this one. Area is equal to 8 sine theta minus 2 theta minus sine 2 theta from 0 to pi over 2. Let's substitute. So 8 times sine of pi over 2, 2 times pi over 2 minus sine 2 pi over 2. Then minus 8 sine 0 minus 2 times 0 minus sine 2 0. Okay, so the result of this one is 8 sine pi over 2 is 8 times 1 and minus pi, and this is sine 2 theta is equal to 0, and minus this will become 8 sine 0 is equal to 0, and this is 0, and sine 2 theta, sine 2 0 is 0, so therefore this is 0. So the area is equal to 8 minus pi square units. So for this is number 1. Again, this is the region covering from 0 to pi over 2. The next is find the area which is inside the circle. R is equal to 3 cosine theta, and outside the cardioid, R is equal to 1 plus cosine theta. Okay, find the area inside the circle, then outside the cardioid. Okay, this one. Okay, the first thing that we're going to do, again, is we need to find the intersection here. What is the intersection here? And what is this intersection? So based on the graph, that is pi over 3. But we have to solve. R is equal to 3 cos theta, and other R, or the cardioid, is 1 plus cos theta. So we're going to equate cos theta is equal to 1 plus cos theta. So therefore we have here 3 cos theta minus cos theta is equal to 1. So cos theta is equal to 1. Okay. 2 cos theta rather. So we have here cos theta is equal to 1 half. Sorry, theta is 1 inverse of 1 half. So first is the theta. If we're going to look at here, this is symmetrical. Again, this is symmetrical. Okay, symmetrical here. Okay, so the angle for this one is inverse cos of 1 half is pi over 3. So pi over 3. So the intersection, if that is pi over 3, that is cosine is 1 half. So our intersection is, the radius is, we have pi, 3 halves and pi over 3. Okay, 3 halves and pi over 3. Okay, 3 halves and pi over 3. Here, this is 3 halves and pi over 3. So, okay. So, the first we have now, so we could have from 0 here and going to the intersection, which is pi over 3. So, the area now is, since this is symmetrical, so we're just going to multiply it by 2 twice from 0 to pi over 3. And this is 1 half. And the inner, this one is, the circle is 3 cos theta. And the inner one is r is equal to 1 plus cos theta. So therefore, the circle is the outer 3 cos theta squared minus 1 half, okay, 1 plus cosine theta squared d theta. So we could cancel this part all because we have 2. Area is equal to, from 0 to pi over 3, this will become 9 cosine squared theta minus 1 plus 2 cos theta plus cosine squared theta d theta. Okay, the area is equal to 0 to pi over 3. So 9 cos squared theta. Distribute this one. This will become minus cosine squared theta minus 2 cos theta minus 1 d theta. So the remaining is 0 pi over 3. This is 8 cos squared theta minus 2 cos theta minus 1 d theta. Okay, so let's copy this one. Our area is equal to 8 cos squared theta. Area is 0 to pi over 3. 8 cos squared theta minus 2 cos theta minus 1 d theta. And the equivalent for this one is 1 plus 2 cos theta over 2. So area is equal to 0 pi over 3. So 8 times 1 plus cos 2 theta over 2 minus 2 cos theta minus 1 d theta. So this will become, area is equal to 0 pi over 3. This will become 4 plus 4 cos 2 theta okay, 4 plus 4 cos 2 theta minus 2 cos theta minus 1 d theta. And okay, we could simplify 4 and 1. So area is equal to 0 pi over 3. This is 3 plus 4 cos 2 theta minus 2 cos theta d theta. So we are going to integrate now. Area is equal to 3 theta plus 4 times 1/2 the neutralizing factor sine 2 theta minus 2 sine theta from 0 to pi over 3. Area is equal to 3 theta plus 2 sine 2 theta sine 2 theta theta 0 pi over 3. Area is equal to, okay, we have 3 times pi over 3 plus 2 sine pi over 3 minus 2 sine pi over 3, then minus 3 times 0 plus 2 sine 2 times 0 minus 2 sine 0. The area is equal to, okay, so this will become pi over 9 plus 2 sine theta, sine or compute sine pi over 3 alpha pi over 3 square root 2 times the square root of 3 over 2 minus 2 sine times pi over multiplied by 2 times 2 times this one is square root of 3 over 2 sine 2 pi over 3 minus this is pi over 3 that is square root negative square root of 3 over 2 then minus times 0 sine 2 0 equals 0 and this is 0 and this is 0. So the remaining one is area is equal to pi 3 pi over 3 is pi cancel, rather this is pi, okay, pi. So then cancel, and this one is cancel. The remaining is pi square units. So that's it for problem number 2. That is the area. Next, let's proceed with determine problem number 3. Determine the area that lies inside r plus 2 sine theta and outside r is equal to 2. So the first thing that we're going to do is we're going to analyze and graph. The first is we need to solve for the intersection. The intersection is 3 plus 2 sine theta is equal to 2. 2 sine theta is equal to 2 minus 3. So sine theta is equal to negative 1. So sine theta is equal to negative 1/2. So our theta is inverse sine of negative 1/2. So what part here? So let's solve negative 1/2. Inverse sine negative 1/2. That is negative pi over 6. Okay. This one, negative pi over 6. And going here, since determine the inside R. Inside R is equal to 3 plus 2. Inside here, this is inside R. And outside the 2. Here. And the other one, so the other one, if we're going to connect here, the intersection here is, the next is pi is equal to negative pi over 6 and 7 pi up to 6. So this one. So we have now the boundaries from here, because we need to get until this intersection. So the area is equal to the whole. Okay, the whole area here that we're going to get. So area is equal to 1/2. The boundaries is from negative pi over 6 to 7 pi over 6. Again, we are going to compute what is the intersection here. Aside from this side, right, we have also the intersection here based on the illustration. So the thing that we're going to do is we need to graph to check. So I graph already so that it would be easy for me to illustrate. But during your work, you're going to graph. So this one, so the outer is, this one is the outer and this one is the inner. So outer is 3 plus 2 sine theta squared minus the outer is 2 squared, then d theta. So we are going to simplify. Area is equal to 1/2 negative pi over 6, 7 pi over 6. This will become 9 plus 3 times 2, 6, 12 sine theta plus 4 sine squared theta minus 4 d theta. We have to simplify. Area is 1/2 negative pi over 6 to 7 pi over 6. This is negative and 9. This is 5 plus 12 sine theta plus 4 sine squared theta d theta. And the equivalent for this one is 1 minus 2 cos theta over 2. Okay, we need to simplify. Area is equal to 1/2 negative pi over 6, 7 pi over 6, then 5 plus 12 sine theta plus 4 times 1 minus cosine 2 theta over 2, then d theta. So simplify further. 1/2 negative pi over 6 to 7 pi over 6. This is 5 plus 12 sine theta. This is plus, okay, 2 minus, this is 2 cos sine 2 theta d theta. This will become 7. Area is equal to 1/2 negative pi over 6 to 7 pi over 6. This is 7 plus 12 sine theta minus 2 cos 2 theta d theta. So we need to integrate now. So this is area is equal to 1/2. Okay, integrate. So 7 theta And derivative of integrate this one. What is the integral of cos? Okay, let's check. Okay, the integral of sine is equal to negatives, okay, 12. This is cos theta because okay, the integral. Okay, integral of sine u du is equal to negative cos theta minus 2. This is 2, okay, times, okay, 2 times 1 half sine 2 theta d theta. So cancel. So area is equal to 1 half 7 theta minus 12 cos theta minus sine 2 theta from negative pi over 6 and 7 pi over 6. So let's solve here. Area. So let's copy. Area is equal to 1 half 7 theta minus 12 cos theta minus sine 2 theta negative pi over 6 to 7 pi over 6. So, no, included here 1 half. Okay. So we need to simplify first. 7 pi over 2 minus 12 cos theta over 2 minus sine 2 theta over 2 from here negative and 7 pi over 6. So area is 7 times 7 pi over 6 over 2 minus 12 cosine of 7 pi over 6 over 2 minus sine 2 7 pi over 6 over 2. Then minus 7 negative pi over 6 over 2. Then minus 12 cos negative pi over 6 over 2 and minus sine 2 7 pi negative pi over 6 over 2. Okay, so this would become 49 pi over 12 minus, let's have cosine 7 pi over 6 is equal to 12 times negative square root of 3 over 2. This is negative over 2 over 2 minus sine, minus sine 2 times 7 pi over 6 square root of 3 over 2 divided by 2. Then this is negative, that's plus 7 pi over 12 and 12 cos negative pi over 6 is equal to square root minus, this is minus, the result is positive, so therefore plus 12 square root of 3 over 2, then over 12 cos negative pi over 6 over 2. Then this will become sine 2 theta, sine 2 times negative pi over 6. Okay. This is negative and negative square root of 3 over 2 over 2. Okay. So negative. And this is become 49 pi over 2 plus 7 pi over 12 rather. And this is plus 12 square root of 3 over 4 plus 12 square root of 3 over 4 minus square root of 3 over 4 minus square root of 3 over 4. If we're going to calculate this one, so 49 pi over 12 plus 12, 7 pi over 12 plus 2, 12 square root of pi over 4 plus 12 square root of 3 over 4 minus square root of 3 over 4 and minus square root of 3 over 4. The result is 11 square root of 3 over 2 plus 14 pi over 3 square units. Okay, for that is for example number 3. Let's proceed with example number 4 rather. This is 4. Okay, determine the area of the region outside R is equal to 3 plus 2 sine theta and inside R is equal to 2. So we have already taken the intersection, so therefore this is now the illustration. Since the question here is outside the region, outside the R, so our R here is outside here and inside the R2. R is equal to 2. So our limit here from area, our bound here was 1/2 from 7 pi over 6 to going here is equal, this is equivalent positive, that is pi 11 pi over 6. And we need to get the outer. The outer is, we have 2 squared. Okay. The outer is 2 squared minus the inner is 3 plus 2 sine theta quantity squared d theta. This is the inner part and this is the outer. So 1/2 integral of 7 pi over 6 and 11 pi over 6. this will become 4 minus 9 plus 12 sine theta plus 4 sine squared theta d theta. Then after, we are going to simplify 1/2 7 pi over 6 11 pi over 6. So they have 4 minus 9 12 sine theta plus 4, and this is minus 4 minus 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 and minus 4 1 minus cos 2 theta over 2 d theta. So let's simplify first this y. So this is negative 5 minus 12 sine theta minus 2 minus 2 cos 2 theta. Okay, we have to simplify further. This is plus rather because it's negative and plus. So negative 5, negative 12 sine theta minus 2, 2 sine theta. So you have to combine this. So this becomes negative 7 minus 12 sine theta plus 2 cos 2 theta. So, and we have here 1/2 multiplied by 1/2. So the remaining is negative 7 over 2 minus 6 sine theta plus cos 2 theta. Okay, next is we need to integrate now. The area is equal to integral of negative 7 over 2 minus 6 sine theta plus cosine 2 theta d theta from 7 pi 6 to 11 pi over 6. So we have here area is equal to negative 7 over 2 theta, then the integral of sine plus this will become 6 cos 6 cos theta. Okay, because this is negative, then plus cosec theta plus 1/2 sine 2 theta from 7 pi over 6 to 11 pi over 6. So we will now substitute here the given area, the pi. So we will copy this negative 7 pi, negative 2, 7, 2 theta plus 6 cos theta plus 1/2 sine 2 theta. Copy here. Area is equal to negative 7 over 2 theta plus 6 cos theta plus 1/2 sine 2 theta from 7 pi over 6 to 11 pi over 6. Substitute here. Negative 7 over 2 times 11 pi over 6, then plus 6 times a cosine of again 11 pi over 6 plus 1/2 sine 2 times 11 pi over 6. Then minus, this is negative 7 pi 2 over 7 pi over 6 plus 6 times cosine of 7 pi over 6 plus 1/2 sine of 2 times 7 pi over 6. Area. Area now is negative 77 pi over 12 plus 6 cosine of 11, 7 pi over 6 as 11 pi over 6. So let's have first cosine of 11 pi over 6, that is the square root of 3 over 2 plus 1/2 sine 2 theta, okay, minus sine 2 theta, okay, sine 2 times 11, this is 11 pi, 11 pi over 6, okay, this is negative square root of 3 over 2, then minus 49, negative 49 pi over 12, then plus cosine of 7 pi over 6, that is 6 times negative square root of 3 over 2, then sine 2 times 7 7 pi over 6 is square root plus 1/2 square root of 3 over 2. Okay, so simplify. Negative 77 pi over 12 plus 6 square root of 3 over 2 minus square root of 3 over 4 plus 49 pi over 12 plus minus then plus, so plus 6 square root of 3 over 2, and this will become minus square root of 3 over 4. Okay, so we have to simplify. So negative 77 pi over 12 plus 49 pi over 12 plus, okay, plus is plus 6 square root of 3 over 2 plus 6 square root of 3 over 2 minus square root of 3 over 4 minus square root of 3 over 4. The area is 77 minus 49 divided by, okay, negative 7 over 3 pi. Then we are going to add this one. Okay, 6 square root of 3 over 2 plus 6 square root of 3 minus square root of 3 over, that is plus 11 square root of 3 over 2 square units. Okay, this is negative. So that's all for problem number 4. So try this at home. So find the area which is inside the circle for cos theta, and outside the circle r is equal to 2 cos theta. And find the area which is inside the lemniscate, r squared is equal to 8 sine 2 theta, and outside the circle r theta. So thank you so much for listening, and please submit this one during our class. Please try this.